So in this video we are going to solve some important questions of integral calculus. Let's move to that one. This is our first question. So in this question first we have to convert, or we can write tan x as sin x by cos x. Okay, so we are writing tan x as sin x by cos x dx. After that, integration. If you take LCM and then calculate, it will be cos x plus sin x. In numerator it will be 1 dx. It is nothing about reciprocal. So if you take reciprocal, it will be cos x by cos x plus sin x. Okay. Now one interesting thing we have to do. Let's see what I am doing. I have taken 2 cos x. Why? Because in next line I am going to split these 2 cos x into 2 separate functions, by which I can solve this question easily. If it is half, then 2 cos x can also be written as cos x plus sin x. Okay, then plus cos x minus sin x. Okay, if you calculate this numerator, you will get 2 cos x. In numerator, in denominator it is cos x plus sin x dx. Okay, so now we can split it. That is cos x plus sin x upon cos x plus sin x dx, also half into cos x minus sin x by cos x plus sin x dx. Clearly you can see this both numerator and denominator same, so by cancelling out we are getting 1, so easily it will be only dx. The second one, if you clearly see, you can see that this fraction is having differentiation of denominator in the numerator. See, cos x is having minus sin x and sin x is having its differentiation as cos x. So exactly if you take that differentiation, let me show you the differentiation. Okay, if you take differentiation, that means ddx of that cos x plus sin x, you are actually getting minus sin x plus cos x, which is nothing but our that numerator. Okay, so for this formula we know that it will be log modulus of this denominator cos x plus sin x. Okay, it is clear, or you can write the reason also, and that means integration of f dash x divided by fx dx is always give you log mod fx. Okay, this is a formula we have used here. In first case, if you take the integration of dx, it is clearly x plus half into log mod cos x plus sin x plus 1 constant. Okay, if you take half common, or you can leave it here. Okay, if you want to take, you can x plus log mod cos x plus sin x plus c. Okay, that's all. Now let's move to our next question. Okay, this is our next question. This is kind of a question by which, let take this function. Our function is x plus 1 by x minus 3 into x plus 2. We can assume that function is capital A by x minus 3 plus capital B by x plus 2. Okay, if we do our calculation, then in left hand side it will be same as x plus 1 by x minus 3 x plus 2. And right hand side, if you take LCM, it is x minus 3 into x plus 2, and on that side it will be a multiplied by that x plus 2 and b multiplied by x minus 3. Easily, for this function, the value of x cannot be 3 and value of x cannot be minus 2, so we can assume these two denominator can be cancelled out. Then it going to be a multiplied by x plus 2 plus b multiplied by x minus 3. So after calculating, we are getting x plus 1 is actually equals to ax plus 2a, here it is bx minus 3b. Just simple, we are getting x plus 1 is equals to, if we take together all the terms containing x, it will be a plus b into x, and here 2a minus 3b, 3b, sorry, it is 3b, so it will be 3b. Now since it is an identity, so by comparing the coefficients, that means if you compare left hand side and right hand side, if you compare these two, you will get that x is having as coefficient is 1 in left hand side, and then right hand side is having a plus b. So clearly a plus b is equals to 1, and similarly 2a minus 3b is also equals to 1. Constant part, if you compare, this part will be 1, and this x coefficient of x is 1, since a plus b is also 1. So if we solve, then from here you can find the value of a. Okay, a is nothing but 1 minus b. Put that value of a here, it is 1 minus b minus 3b is equals to 1. Then it is 2 minus 2b minus 3b equals to 1. So 2 minus 5b is actually equals to 1. From where 5b is actually equals to 1. Okay, so therefore the value of b is nothing but 1 by 5. Since b is 1 by 5, so a is our 1 minus b, so it is becoming 1 by 1 minus 5, which is 4 by 5. Okay, now if you take that particular fraction, if you see that part, okay, then we can easily put the value. Okay, let me choose another color, it will be clearly visible. So if now we take the original fraction x minus 3 and x plus 2, we know that value is nothing but a by x minus 3, where the value of a is 4 by 5. So we can write it as 4 by 5 by, here we can write the dx by x minus 3, and we can also write it as, it will be b by x plus 2, it is dx by x plus 2. Okay, after that it's very simple, that differentiation, integration, because you are getting differentiation of denominator in the numerator. If you take the differentiation of x minus 3, it is nothing but 1, which is in the numerator. So 4 by 5 into log modulus of x minus 3, and here you are getting 1 by 5 log modulus of x plus 2, and there is a constant. These are answer. Okay, now let's move to our next question. This is the question. It is Actually, we're going to solve by method of substitution, in which we're going to put this 1 plus sine x as let it be z. Okay, so what is going to be that cos x dx is actually dz. So let's move to our integration. So our integration will be, let me write the integration first. Cos x dx by 1 plus sine x, okay, 2 plus sine x. So now I am going to put the value of cos x dx and 1 plus sine x. So let me first write that line like that. It will be easier for you to understand. 1 plus sine x. Now 2 plus sine x is can be written as 1 plus 1 plus sine x. Okay. Why I have written? Because now I am going to put that value 1 plus sine x. Now cos x dx can be written as dz. Okay. And that 1 plus sine x can be written as z. And that is can be written as 1 plus this 1 plus sine x is also z. So now we have to solve that particular integration. So next slide is here, right side, dz by z into 1 plus z. Okay, so see, in numerator we have 1, and 1 can be written as 1 plus z minus z. Okay, dz. Now we can split it. If we split this one, well, we will get that 1 plus z by z multiplied by 1 plus z dz minus z by z into 1 plus z dz. By cancelling out, we are getting it is nothing but dz by z minus it is dz by 1 plus z. So clearly you can observe that we are having differentiation of z in its numerator, which is 1. So it is really log mod z, and in this part you are getting log mod 1 plus z, because if you take differentiation of 1 plus z, it is also 1. Now it is having log is having in subtraction, so it would be log z by 1 plus z. Now put the value of, sorry, here will be a constant c plus c. Now you have to put the value of z, because in question it is in the term of, in the function of x. So log z is having its value as 1 plus sine x, and in denominator it will be 1 plus, put the value of z 1 plus sine x. Okay, last line is log 1 plus sine x divided by 2 plus sine x plus c. Okay, let's move to next one. This is again a substitution problem. Put x minus 1 by x as z. Now if you take differential, then it will be 1 minus 1 minus, if you take differentiation of 1 by x, it will be minus 1 by x square dx is going to be dz. After that we are getting 1 plus 1 by x square dx, or it will be dx. Okay, dx is dz. So writing integration as 1 by x, it is 1 plus 1 by x square dx. Now it is going to be e raised to the power z. Okay, because the value of x minus 1 by x is z, and here this whole value is actually dz. Now clearly you can see that integration of e raised to the power z is actually e raised to the power z plus c. Now put the value of z. Z is nothing but x minus 1 by x plus c, which is the easiest one.